I had a few questions about number 17 on the Chapter 8 review, and it's interesting because when I tried it, the first thing I tried didn't work. I looked at this problem and I said, I need a proportion here, so I'm going to prove these two triangles are similar. I'm going to prove their corresponding parts are proportional. And then I noticed, oh wait, OP, that's not a side of one of the triangles. And what I thought I was going to be able to do, I thought I was going to be able to show that this was a parallelogram and like maybe substitute OP in place of like SR or something like that. Anyway, tried it over and over and over again. Didn't work, okay? And it's because I didn't look at the problem very carefully. So a lot of you may have not made the same mistakes I did, but anyway, it's very possible that some of you did. So here are a couple of keys. And by the way, I'm not going to write up the two-column proof. I'll let you write it up, but I'm going to give you kind of the background that you need to be able to do it. Angle 1 and 2 are congruent, okay? That also tells me that this triangle is isosceles, so we're going to have two congruent sides here and here, okay? I've got vertical angles here, okay? So this angle is going to be congruent to that angle over there as well, okay? Not sure if that's going to be needed, but you know, it never hurts, okay? Actually, you know what? I'm not going to use that just yet. Let's leave that out. All right, so notice the other thing they told you is that OS is parallel to PR, okay? This is OS, that's PR, okay? I'm going to put it right here. And the second run through this problem is when I realized this isn't necessarily a straight similar problem, a triangles problem. This is a side splitter theorem problem, okay? In other words, I've got a side parallel to a base, and notice what that's going to give me. If a line is parallel to a base of a triangle, then it divides the opposite sides of the triangle proportionally. That's the wording of the side splitter theorem. So we know that MO over OP is going to be equal to MT over TR, okay? And if you notice, that almost perfectly matches the statement except for TR right here. And that's when I realized, oh, that's an isosceles triangle. So I would like to get rid of the TR here, and I'd like to replace it with the SR. Because that triangle is isosceles, I know those two sides are equal. So you can do a substitution, and you can put SR in place of TR in your statement, and you're going to have that. So this is just a side splitter with a substitution coming from an isosceles triangle. You're not actually going to have to prove these two triangles similar, and I'm not even sure if you have the information to be able to do that. So that was something that threw me off, and I'm guessing it probably threw some of you off too, but actually not a very long proof. Just make sure you look up the wording of the side splitter theorem so you can use it in two columns.